Hello and welcome to week 3 in Statistics for Psychology, and we take an adventure into chapter 2 where we're going to learn about data and distributions. Now first off, understand that data is any sort of collection of information that we have. Now, in the field of psychology, we make a distinction between data that has systematically been collected and anecdote, which is the information that we have within our own minds about observations we have made directly. Now, as human beings, we operate in the world using primarily anecdotal data. We move around and we gather information about how the world works, and we pretty much operate that way. Now, in psychology, there is a distinction made between data and anecdote, meaning that data is the result of a systematic gathering of that, following the scientific method. Anecdote is subject to our own selection. Just think about perception and what we select to pay attention to, our biases, our blind spots, our heuristics, all of those things that contribute to how we select information to store in our brain. So there's an old adage within psychology, and it's the plural of anecdote is not data. So no matter how much experience or how much exposure someone has had to a particular sort of thing, someone might consider themselves an expert, and they may very well be an expert on something, but that's not the same as data. So we're going to be focusing on information that has been gathered systematically, in a way that meets the scientific method. Now, when we have that kind of information, we refer to it as a distribution. And that's a different use of the word distribution, where we might think about, let's say, somebody's distributing flyers, or how frequent the coronavirus is in a particular geographical area, the distribution of that virus. A distribution is a single word to describe a particular set of data. So we might even say, this is the data I collected, or we might say, this is the distribution of the numbers. The distribution is a noun describing that collection. Now we're going to be looking at the frequency of particular numbers and values within that. But before we go into that particular aspect of today's chapter, we want to recognize that there are different types of data, and as we'll see through this course, the type of data that we collect systematically determines our choice for which statistical tools we can use to analyze that data. So if we're looking at the different distributions, the different scales as we talk about them, we have nominal. This is right from your course book. We have nominal, which is the unordered categories of things like apples and oranges, or different universities. And then there's ordinal, which is like nominal, but they're in a particular order. There's no actual calculatable numerical value to A, B, C, D. All we can really report out is the frequency, how many A's, how many B's, how many C's, whatnot. Then we go into interval. Now, an interval is numbers, it's expressions of numbers that don't have a 0 point. Now, this is a mathematical distinction that's made. Often we use the same statistics with both interval and ratio data, but interval data does not have a true 0 point. So let's just say values on a Likert scale, like the 1 to 5, when you rate 1 to 5, 1, 2, 3, 4, 5. Those are numbers, but they don't really have a 0 point. Now, the mathematical distinction of that is, if you're doing a Likert scale, you're doing your evaluation of my performance in this class, and you Mark was approachable, and you can say 1, 2, 3, and 4, and 5. You have those 5 responses, with 1 being totally unapproachable and 5 being totally approachable. Now, the difference between a 3 and a 4 and a 4 and a 5 is not quantifiable. That's your personal feel of that. There's no actual 2.3. That doesn't make any sense. This is a rating scale where there's distinct numbers. You can see it's still numbers and we can still play around with them, but the difference between a 1 and a 2 and a 2 and a 3 and a 3 and a 4, that could be, there's no way to quantify that. It all depends on how you interpret and feel that question. So that's where we sort of get that idea of interval data. Now, ratio data is measurement. Inches, height, distance, time, temperature, all of those measures kind of thing where we get an exact score, like the actual numerical grades. There is a difference between a 12 and a 12.5 on a test. And so there's those minute differences, the minutia get down into that ratio data. And as we explore each one of the ways in which we manipulate numbers, you'll see that we'll be spending a lot of time in interval and ratio data. That's sort of the gold standard when we're using statistics. And then we'll look at some statistics that we can use for ordinal and nominal data. Now, when we want to present that information, and this leads to kind of the assignment that's coming up this week, when we want to be able to take information, present it, one of the first ways that we do that is with a frequency distribution. So let's just say we wanted to know, maybe it's a little easier even to think about nominal data this way. We want to know how many, or ordinal data, how many first-year students, second-year students are in the KVCC population. So we can count up all the first-year students, however many they are, the frequency of that, and the frequency of second-year students. And we could create a bar graph called a histogram that actually visually represents those numbers in a graphic way so that we can compare them. Now, in the book, I used the example of the hours of sleep per night. And we see here that on the left side of this table, you see the scores, the possible scores within our distribution, which is just above there. There are 5s in there, there are 6s, 7s, 8s, 9s, and 10s. And then the next column is how many of each one of those are in that distribution. How many 5s are there? There's 2 of them. How many 6s are there? There's 4 of them. And then the graph, along the bottom we have the values, and then the bars represent the number of each one of those values. And we can see that it sort of jumbles around the middle. 6, 7, and 8 are the highest, and it tapers off to the right in terms of 9 and 10, and it drops down to the left in terms of 5. So that itself, the shape of this actual distribution, is another thing that we're going to look at. Whether it leans to one way or another, or whether it's evenly distributed in the middle, is a value that we call skew, that you're also going to be learning about in this particular chapter. So chapter 2, data and distributions, there's a discussion, there's a quiz, and then there's an assignment. And the assignment, you are actually going to have to do some research on how to do this, because I'm asking you to do a frequency distribution, which is fairly easy, but you're doing it over a range of numbers. So instead of single numbers coming down, now how many 5s is, how many 6, how many 7 is, we might change that graph to how many people got 5 to 7, how many got 8 to 10. We want to simplify that data, let's say. So we have to group together the 5s, 6s, and 7s, and the 8s, 9s, and 10s. And you could do that within Excel, but you're going to have to look up how to do that. Again, I'm not only trying to teach you how to use Excel in these manners, but I'm teaching you how to use your own problem-solving skills and research skills to find out how to do something. So this is a kind of a challenging assignment in that I'm not offering you all of the information. You have to go out and find some of it about how to actually do a range of numbers in a frequency distribution table and then convert that into a distribution chart, or the histogram, the bar chart. So that's what's in front of you today. I hope you have a great week. We experienced a whole bunch of snow. I'm right all pumped up with muscles now because I shoveled so much of it. And so I hope you're having a good beginning of the week, and I will see you in the discussions. And please reach out if you have any specific questions. Have a great day.